All right, we're going to get started with the 7.5 notes. And in this lesson, we are going to look at solving equations that have logarithms in them. So the first thing that I want to kind of recap is we talked about logarithmic form and how to change back and forth between logarithmic form and exponential form. Like, for example, saying that log base y of x equals -8 is the same thing as saying y to the -8 equals x. And we practiced that in our previous class. So same thing here. Log base 2 of v equals 8 is the same thing as saying 2 to the 8th equals v. And this idea is going to be really important for us in this next example. So if I have a logarithmic equation, so let's say I have log base 3 of x minus 5 equals 2. What we're going to do, the key is to rewrite in exponential form. We're going to rewrite it in exponential form. So we're going to use our little circle method here. Start at the base and circle around. So this is the same thing as saying 3 to the second equals x minus 5. And now that we've done that, it's really quite a simple problem. So 3 squared is 9. And then I can add 5 to both sides. So x would equal 14. Let's try another one. Log base 4 of x squared equals 7. I'm going to rewrite this in exponential form. So I get 4 to the 7th equals x squared. Now, I don't know 4 to the 7th off the top of my head. Maybe you do. But I'm going to grab my calculator. 4 to the 7th, wow, is 16,384. Now, to undo a square, we take the square root. So let's see if this is a perfect square. 16,384. It is indeed a perfect square. So that means x equals plus or minus 128. All right. Let's try one more here. Let's say I have log of 3x plus 1 equals 2. Remember, when you have a log that doesn't have a base, that means this is really base 10. So when I rewrite this in exponential form, I'm going to have 10 squared equals 3x plus 1. 10 squared is 100. And now I can solve for x from here. Subtract 1 from both sides. And then divide by 3. So x equals 33. All right, now, the other things that we talked about is that if you have two logs being added together, that's the same thing as multiplying the two things together. And likewise, if I'm subtracting two logs, to combine them together, I actually divide those two things. So we're going to keep that in mind as we try the next couple of examples here. So example 4. Let's say I have log 45x minus log 3 equals 1. So first thing I'm going to do is combine the logs. So when I subtract logs, I divide what we're taking the log of. So this is going to become the log of 45x divided by 3. And 45 divided by 3 is 15. So now this is just like the first 3 examples we did. I can now rewrite it in exponential form. And remember, when I don't have a base written, that's really a base of 10. And that's just 10. 10 to the 1 is just 10. So I'm going to divide both sides by 15. 10 fifteenths can simplify to 2/3. All right, now we are going to use a couple properties. Before I can add these together, I need to take care of this in front. Now, before, we really only brought the exponent out, but if I have a number multiplied in front, I can move it inside as an exponent. So this becomes log 5 plus log x squared equals 2. Now, when I add 2 logs together, that's the same thing as multiplying the 2 things that we're taking the logs of. And just like before, I'm going to rewrite it in exponential form. So I'm going to have 10 squared equals 5x squared. This is 100. Divide both sides by 5. We get 20 equals x squared. Now I'm going to take the square root of both sides. And 20 is not a perfect square, but there is a perfect square that goes into it. So we get plus or minus 2 square roots of 5. Now, I actually can't have the negative because if you remember, we can't take the log of a negative number. So my only answer is 2 square roots of 5. All right, next kind of idea here. If I have an equation where I have logs on both sides. So if one log equals another log, that must mean that those two things are equal to each other. So for example, let's say I have, so example 6, log base 2 of 7x equals log base 2 of 2x plus 5. What that means is that these two things must be equal. So my equation can literally just be 7x equals 2x plus 5. And now I can solve from here. So I'm going to get x's all on one side. and then divide. So x equals 1. Okay, last thing. We talked about how exponents or exponential equations and logarithms are inverses of each other. So here's the key idea. When x is in the exponent, log both sides. Log both sides. So what do I mean by that? Let's say I have 5 to the x minus 2 equals 200. So my x is in the exponent. And what I'm going to do is I am going to take the log of both sides. Log of that and log of that. Okay? Now I am going to use the property where I can bring an exponent down to the front. So I have x minus 2 times log 5 equals log 200. Now, this is where our calculator is going to come in handy. What I'm going to do is I am going to divide both sides by log 5. And I'm just going to use my calculator to do it. So log 200 divided by log 5. So x minus 2 equals 3.292. And all I'm going to do now is add 2. So x is 5.292. And I know it's kind of weird that we don't normally get weird answers like this, but in this case we will. So let's try one more like that. Let's say I have 3 to the 2x equals 11. What am I going to do? I'm going to log both sides. Then I'm going to move the exponent, that's our power rule, to the front. So I have 2x times log 3 equals log 11. Now I'm going to divide both sides by log 3. So I'm going to go to my calculator and do log 11 divided by log 3. And I get 2.18. So I have 2x equals 2.183. Then I'm going to go ahead and divide by 2. So I get x equals 1.091. And there you have it. That is it for the 7.5 notes. We will definitely do practice with this when I see you in class next time.